In lesson 8.4, we're going to be talking about angles of elevation and angles of depression. We're still going to be talking about or using our trig ratios. Taking a look at our diagram here, an angle of elevation is the angle formed by a horizontal line and a line of sight to a point above the line. An angle of depression is the angle formed by a horizontal line and a line of sight to a point below the line. So let's take a second and just look at our diagram here. Angle of depression. We know depression means down, right? From the horizontal, an angle of depression opens up going down. Angle of elevation. Elevation we know means when you elevate, you raise it up. So from the horizontal, an angle of elevation opens going up. Really, the key is to look at what the relationship is according to the horizontal line. Down below you'll see, since horizontal lines are parallel, angle 1 and angle 2 are actually going to be alternate interior angles. And so angle 1 would be congruent to angle 2. They're going to ask us to take a look at some diagrams and just identify the type of angle that we have. Remember, this is according to the horizontal. So from this horizontal line, angle 1 opens up going down. So it would be an angle of depression. Take a second and think about what you would label for angle 2, angle 3, and angle 4. Again, the key is to look at the horizontal line and how your angle opens from there. Hopefully your answers match mine, that we have angle 1 was depression, 2 elevation, 3 depression, and 4 elevation. Now we're going to take a look at solving some word problems. In example B, it says an air traffic controller at an airport sights a plane at an angle of elevation of 39 degrees. The pilot reports that the plane's altitude is 4,000 feet. What is the horizontal distance between the plane and the airport? Round to the nearest foot. Now sometimes when I'm solving word problems, I actually like to read them one more time to just kind of process. And then what we're going to want to do is we're going to want to sketch our diagram and label what we know. So the air traffic controller at the airport sights a plane at an angle of elevation of 39 degrees. So I'm just going to say that down here is my airport, and that's where my air traffic controller would be. And this person is sighting my plane, which I'm not a very good artist, but here's my plane, at an angle of elevation of 39 degrees. So if this is my horizontal here, and they're sighting my plane, angle of elevation would be this angle right in here, 39 degrees. Now it says my plane has an altitude of 4,000 feet. Well, the word altitude means height, and so if I'm going to label that, altitude has to meet my horizontal at 90 degrees, and so this is what we would consider the altitude. Now what are we looking for? We're looking for the horizontal distance between the plane and the airport. Well, the horizontal distance would be right down here. That would be x. We are going to solve for x. What would they call it if I were solving for the hypotenuse? Well, that is something that they would call the direct distance. So this is the direct distance. This would be the horizontal distance. Now, setting up to solve, if I worked off of my 39-degree angle here, my 4,000 feet, well, this would be opposite side, and I'm solving for the adjacent. So using my SOHCAHTOA, I know opposite and adjacent, we're going to use the tangent function. So I'm going to set that up. The tangent of 39 degrees would be equal to opposite over adjacent. We had talked before when we solve these, setting up our proportion, our cross products are equal, and so calculating 4,000 equal to the tangent of 39 times x. We know that we need to divide by tan 39. And so then we're going to grab our calculator here, and we're just going to take 4,000 divided by tangent of 39. Now they asked me to round to the nearest foot, so it looks like to the nearest foot, this would round up 4,940 feet. So I'm running out of room here, but I'm going to say x is about 4,940 feet. Okay, let's take a look at another one. In example C, it says that Nolan is flying a kite. The angle of elevation to the kite is 43 degrees, and the kite's altitude is 20 feet. How much string is Nolan using to fly the kite? Okay, so let's do a little bit of a sketch here. We have Nolan, and he's flying a kite. Now we know if we're using our trig that we actually are working with our triangles. So I know that I'm going to be having my right triangle here. It says the angle of elevation is 43 degrees. Again, which angle would that be? Here or here? Well, opening from the horizontal, that means that 43 degrees is going to go down here. That's my angle of elevation. The kite's altitude is 20 feet. My altitude has to be straight up and down or meeting at 90 degrees. We want to know how much string Nolan is using. So in this case, solving for my missing length, I'm actually looking here to solve for y, the amount of string. So taking a look at example C, here I have opposite side and my hypotenuse. That tells me that this time I'm going to use my sine function, opposite over hypotenuse. And again, we would simply set up our cross products. And in the end, we would find out that we would need to take, to solve for x, we would have the 20 feet divided by the sine of 43. So I'm going to go ahead and take 20 divided by the sine of 43. Now this one does not tell us what to round to. So when it doesn't tell you what to round, I like to at least round it to the 10th. So it looks like it's going to be approximately 29.3 feet. I guess I go that way. Calling that y instead of x. Y is about 29.3 feet. Underneath that, the question is posed, what if, suppose the amount of string being used was 33 feet and the kite's altitude was 20. What would the angle of elevation be? So they're kind of changing what they're asking. If I had my little triangle here, the amount of string would be 30 feet and my altitude's still 20, I'm wondering about the angle of elevation. So I'm wondering what that angle would be. Again, we are thinking about using the sine ratio, but here I'm looking for my angle measure. So I'll remind you that it would be set up something like this. The sine of x would be opposite over hypotenuse. And remember that we said in order to find our angle measure, we're actually thinking about taking the inverse sine of 20 over 33. And so when I calculate that, I just have to make sure that I have the inverse sine. So I have it to the negative 1 here, 20 divided by 33. And my angle of elevation, looks like my angle would be about 37.3. Okay, question 2. Question 2 says a forest ranger in an 85-foot observation tower sees a fire. The angle of depression to the fire is 8 degrees. What is the horizontal distance between the tower and the fire? Round to the nearest foot. So again, this one is going to be similar. I'm going to process a little bit and sketch my picture. I have an 85-foot tower. Okay, let's draw my tower. And my forest ranger is up in that tower. He sees a fire. So I'm going to take fire over here. And says the angle of depression to the fire is 8 degrees. Okay, well, first of all, my tower is 85 feet. So 85 feet above the ground. Seeing the fire is an angle of depression at 8 degrees. A lot of times kids want to label this angle in here at 8 degrees. But our angle of depression actually comes off of my horizontal. Remember, angle of depression has to open down. So this angle in here is actually what would be labeled my 8 degrees. Now, I could still solve using a triangle this way, but if this is 8 degrees, the other thing that is true is this angle down here is going to be 8 degrees. So that's how our angle of depression works a little bit differently. I'm wanting the horizontal distance, so here I'm solving for my ground distance of x to the nearest foot. Well, from my 8 degrees, if I use this triangle on the bottom, I have opposite and adjacent. I'm going to use the tangent function. The tangent of that 8 degrees is equal to opposite over adjacent. My cross products would tell me that x is going to be 85 divided by the tangent of 8. And so then we would simply calculate to the nearest foot, 85 divided by the tangent of 8, and it's about 605 feet. Calculating the answers aren't usually all that difficult. The hardest part is getting your picture drawn and making sure you accurately label everything. Now, underneath that, it poses the question that what if the ranger sees another fire at an angle of depression of 3 degrees? What is the horizontal distance? So if you think about this same setup and the forest ranger sees a second fire at an angle of depression of 3 degrees, would that fire be closer to the tower or farther away than the original? Well, if this angle is going to decrease 3 degrees, well, that would put my fire farther away, correct? So here I actually can use my same setup, but instead I'm thinking about a 3-degree angle, and we know it would be farther away. So when I take my 85 and divide by tangent of 3, I should get a larger answer. And in fact, if you were to calculate that, you should find that you get about 1,622 feet. Okay, let's look at the last one, example D. In example D, it says that a pilot flying at an altitude of 2.7 kilometers sights two control towers directly in front of her. The angle of depression to the base of one tower is 35 degrees. The angle of depression to the base of the other tower is 55 degrees. What is the distance between the two towers? I'm going to first start by sketching what I know. My pilot is flying her plane at altitude of 2.7 kilometers. So if here's my plane and the altitude at 2.7 kilometers. My pilot sights two control towers. So let's make our control towers here. We've got tower 1, and I'm going to make a tower 2. And I may not have things drawn to scale, but I'm just trying to get a sketch so I know kind of how I'm going to set up to solve. Now, if my pilot sees these towers in front of her, one is at an angle of depression of 35 degrees, and one's at an angle of depression of 55 degrees. Well, remember, our angle of depression has to come off of our horizontal. Here, the first tower. Well, this angle would be the greatest, right? And so that angle of depression would actually be the largest at 55 degrees. The second one, angle of depression here, would actually be lesser of an angle, and that would be the 35 degrees. Now, what am I looking for? I'm actually looking for the distance between the two towers. So, I'm looking for this right here. Well, if I were going to set up and solve, to use my trig ratios, I actually need right triangles. I know that if this angle of depression is 55 degrees, that actually means that this angle is 55 degrees. Likewise, the 35 degree angle will be here. Well, in this diagram, I actually have two right triangles. I'm going to call it the smaller one and the bigger one, and that's what I'm going to use to solve. First, I'm going to think about solving for x. So here, opposite and adjacent, I'm going to say that my tangent of 55 degrees is equal to the opposite over adjacent. And I'm going to go ahead and calculate that. If I calculate that, I actually left that rounded to the nearest hundredth because I'm going to use this in a further calculation. So when I took 2.7 and divided by the tangent of 55, when I made note of that, I wrote it to the nearest hundredth. Now, as I look at the second triangle, I'm actually going to think about calculating, but here I'm going to be calculating y. I have the same altitude, my angle is what changes. So here I have the tangent of 35 equal to 2.7 over y. And as I calculate that and I round it to the nearest hundredth, 2.7 divided by tangent 35, I find that it's about 3.85. Well, how am I going to figure out this distance here, what I'm going to call z? Well, would you agree that to find z, I can take y minus x would equal z. In other words, I can take my 3.85 minus my And we're going to find, as we approximate, that we get about 1.96. Well, to the nearest tenth of a kilometer, this would actually bump up to say that z is going to be about 2 kilometers. Okay, if you have further questions on this, please step in to see me.